Hi everyone. This video is extension of a series of the videos about AWS Strands Agent Development Toolkit. And we already have discussed how to use the Strands agents, how to use different LLMs in Strands agents, how to use the vented or out-of-the-box tools designed by the AWS development team. We have also seen how to connect AWS Strands Agent to MCP servers, and we have seen how to create voice agents and how to control agent lifecycle with hooks. So here I would like to discuss the agent lifecycle of the voice agents and the hooks anatomy associated with it. So let me quickly start with recap of what the AI agents are and why they appeared. So AI agents are basically wrappers around the large language models. A large language model can answer questions, but agents can do things. The agent loop is what makes the difference possible, meaning large language model cannot implement any actions, but agents can implement those actions. So once large language model generates something like, I need to run web search tool or I need to query weather API, this just stays the text. However, once agent reads LLM output, it is capable of extracting the necessary parameter, associating the API with a particular tool name, and actually implement the tool call, thus implementing the action. This is the main difference and the main advantage of why AI agents have appeared and how they augment large language models. So the standard loop or lifecycle of the agent would look like input and context provided into the agent. The agent is a wrapper which enables LLM reasoning upon the input and context. Then, if there are associated tools and the input and context contain reference to such tools, LLM will help to select the tool, and it will provide special input parameters or input arguments to run the tool execution by invoking the tool function. Then LLM will receive the response of the tool execution and decides whether it has to run a different tool or to rerun the tool. And once LLM concludes that the work is done, it will provide a response. So this is a standard loop of the standard agents. And the anatomy of hooks, which are basically extensible mechanism for extending agent functionality by subscribing to events throughout the agent lifecycle. In this particular case, looks as follows. So first we have the section of the hooks associated with the request start event. Then we have hooks associated with model events or LLM events. Then next we have hooks associated with tool events. And finally, we have hooks associated with request end events. This is the standard lifecycle. In one of my previous videos, I have shown how to design voice agents. So the voice agents are also known as a bidirectional streaming agents. And this changes something in the agent structure. To be more specific, if we talk about standard agents which process only text, then the functionality of this entire loop is synchronous. So first input and the context are provided, then it sends to LLM, then LLM selects tools, do this tool execution, and once this loop is done, we provide the response. And everything is done in synchronous manner, so step by step. At each step, we are performing on a single operation. However, as voice agents are bidirectional streaming agents, this changes this loop, and in this case, the model which is initiated within the bidirectional agent is not invoked on the time then input and context are provided. But so the model is initiated once throughout the life cycle of the bidirectional agent, and it constantly streams and receives events. So that's why we will not be able to intercept before and after events in the bidirectional or voice agents. So how we can implement the hooks and what hooks we can implement for the bidirectional agent, let's have a look through a series of code walkthroughs. So first of all, in the standard case, we will have an agent and we will import necessary hook events from strands.hooks. Let's try to apply the same approach for the bidirectional strands agent. So as I mentioned earlier, bidirectional agents are asynchronous agents. That's why we need async IO. The agent will be defined as BD or bidirectional agent, and we will also need bidirectional audio input output. Now let's import in traditional manner after tool call event and before tool call event from strand hooks. The rest of the code I have explained in the previous video regarding the voice agent and the agents and hooks, but I will give a very brief overview of the code. So basically we define here a custom tool which is called getWeather, and it only returns a phrase replacing the location with the input location. Then we use bidirectional Novasonic model. I will have a separate video dedicated to the analysis and understanding of the model. Here I would like to mention that in contrast to other models, the bidirectional Novasonic model is multi-modal. So it receives multiple modalities. At least it works in text and audio. We will have an in-depth discussion in one of the separate videos regarding that. And then we define a voice agent to be bidirectional agent. So as in the case of a standard agent, we provide the model, we provide a set of tools, and we provide a system prompt. In this case, system prompt is your helpful assistant with access to tools. You should provide answers no longer than 200 symbols. So here I'm trying to control the size of the output provided by the agent. As in our previous example with agent hooks, here I provide the callback functions to be invoked by the, and here I'm subscribing callback functions to events by applying add callback method from hooks module of the agent. So this is the standard way to do the hooks. So now let's try to run this code. Hi there.
Hello, how's it going today?
What is the capital of the United States?
The capital of the United States is Washington, D.C.
What is the current weather in the capital?
The current weather in Washington, D.C. is sunny and 72 degrees Fahrenheit.
Okay. So as you can see, there is only text printout, but no hook events are actually taking place. I also seen the runs, then this code resulted in the error. However, in this particular case, these hooks are just ignored without generating any error. So what is the problem? It turns out that for bidirectional agents, we have to apply special bidirectional events. So whatever events we would have, for example, after tool call event or before tool call event, we should prefix with BD and that will constitute our events. So the bidirectional agent have their own architecture and have their own classes for the hooks events. Also, everything which is related to the voice agent comes from the module strands.experimental. So this is experimental module, and we also have to import the hook events from experimental module, from hooks, from events. So this is a correct way to import the hook events for bidirectional streaming agents, aka voice agents. The rest of the code is basically staying the same as per tool's definition. And we will have to add a sync to the definition of the callback function. Because our agents are originally asynchronous, we will also have to provide asynchronous implementation for the callback functions as well. So now we can apply the same agent hook add callback method to assign our callback function before tool callback to BD before tool call event, and do the same for the after tool callback function to associate it with BD after tool call event. That said, let's run this code. Hi there.
Hello, how's your day going so far?
What is the capital of the United States of America?
The capital of the United States is Washington, D.C.
What is the current weather in Washington, D.C.?
The current weather in Washington, D.C. is sunny and 72 degrees Fahrenheit.
What is 5 multiplied by 7?
5 multiplied by 7 is 35.
Please use tool to calculate 5 multiplied by 7.
5 multiplied by 7 is 35 as calculated by the tool.
Okay, so in this implementation, we can see that we were able to intercept the before tool call event and after tool call event. Also, we have an interesting behavior here. Once I ask the agent to multiply 5 by 7, it did the computation itself without using a tool. But once I asked the agent to use the tool was used, and we were able to see that hooks have intercepted the before and after model call events, and we were able to see the calculated tool invocation indicated by the hooks. So a quick summary here is that in contrast to standard non-BD agents, we will have to use special BD hook events for the bidirectional streaming agents. Also, we'll have to make the callback function calls to be asynchronous by adding async at the beginning of the callback function definitions. On the other hand, the methods to subscribe the callback functions to particular events does not change. So this is the correct way of applying hook events and initiating callbacks in the case of the bidirectional agents. Now let's discuss one more example. As I mentioned, since in the case of bidirectional agent, the large language model is not just called once, it basically maintains a persistent open connections using WebSocket where it constantly streams and receives events. Therefore, once we invoke the agent, the large language model for the bidirectional streaming is actually staying active, and there is no interruption before and after request. It is interrupted through the series of events once we start speaking, but the model itself stays alive throughout the life cycle of the agent. Therefore, we cannot directly intercept events like before and after model call event. So what would be our workaround here? Although the before and after model call event event hooks are not available, we still have the bidirectional message edit event. So as previously, message edit event happens each time we try to populate the general chat history with the message, either produced by user or by the agent. And also we have access to after invocation event and before invocation event. So basically, before agent is initialized and after agent is initialized. So using these free event hooks, we would be able to intercept the inputs and outputs of the model, taking into consideration that we cannot really interrupt the model, but we will be able to see which messages are populated into general chat history. This is the approach for bidirectional agents. One more additional component is to process the messages as in the previous video for agents with hooks and callbacks. I am using auxiliary function message to text, which is basically intercepting the message using the message edit event and checks whether the message content contain text, tool use, or tool result keys, or otherwise it outputs the whole content. So here I am adding 3 callbacks before and after invocation event, followed by the BD prefix. We will use before LLM runtime callback. After invocation event, which is followed by the BD prefix, we will use after LLM runtime callback. And for BD messages edit event, we will use message edit callback, which is using auxiliary function message to text. The rest of the code for the bidirectional streaming agent stays the same. Now, let us run the code. Hi there.
Hello. How's your day going so far?
What is the capital of the United States of America?
The capital of the United States is Washington, D.C.
What is the current weather in Washington, D.C.?
The current weather in Washington, D.C. is sunny and 72 degrees Fahrenheit.
In this example, we can clearly see all the messages coming in and out from the LLM. So before the LLM runtime, this is our BD before invocation event. And we can see that we are even to see even the system prompt, which is managing the LLM. Next, we can see the LLM output as message intercepted by BD message edit event. And for each such event, we are able to see what is actual output of the large language model. However, we are not intercepting the large language model since it works in the asynchronous manner with the constantly open WebSocket, but instead we are tracing the output of the model through the BD message edit event. So this is the workaround how we can still control and check the messages coming into and generated by the large language models like Nova Sonic, which are multi-model asynchronous models, in order to control agent loop or agent lifecycle for bidirectional streaming agent, also known as voice agent. So thank you very much. Please like and subscribe this video and stay tuned for the following up videos. See you soon.